Mark, a very, I think, key element is the capacity of the load cell and to what percentage can you overload a load cell. Maybe not as critical in low capacity scales, but when you get into larger capacity scales, crane hanging scales, it becomes very much more important. So could you elaborate on the load cell capacity and the maximum of safe load?
It's important to remember that a load cell is designed as a spring element or a spring beam, and each one is specifically machined to deflect a given amount under a specific load. So within that parameter, you have a 0, which is when the load cell is at rest, and then full-scale deflection, which is 100% of its deflection, or when 100% of the rated load of the load cell is applied. So for instance, this load cell is a 30 kilogram. So we would apply 30 kilograms at its full scale, and then when that 30 kilogram comes off, the spring element returns to its original shape, and then you achieve a good zero balance. So what about overload? Well, a load cell is designed to have 150% of its rated capacity built in to the mechanical design. So up to 150% of the rated capacity of the load cell, when that weight is removed, the spring element or the load cell itself will return to its original shape and give you a good zero balance return.
Will I get any degradation if I go up to 150%?
No, Rob, you're good up to 150%. We don't like to see load cells used greater than 100%, obviously, but you do have that extra 50% of its rated capacity for a safe overload.
Okay.
The maximum overload is 300%. Now, what we mean by 300% is the load cell will most likely move into mechanical deformation. In other words, it'll bend. So when you remove up to 300%, the load cell will return, but most likely it will not return to its original shape. So you're going to see a zero balance shift, most likely in the positive direction, because the load cell, again, has bent slightly, and the strain gauges see that bend as a deflection, which obviously it is. So, but the 300% ensures that you will not have a mechanical failure.
Great. Thanks, Mark.